The fun part of science is typically the observation of what happens in an experiment, seeing something change or seeing something react violently. Okay, we want to be able to predict what's going to happen and infer why and how something happens, but that doesn't have much power to it if we don't back it up with something. That something is data. We make measurements, we record results in order to substantiate that stuff, to give it some meaning, okay, and to back it up. Okay? Now, in science, we want to try and match the rest of the world so that our data can be compared easily to other places, okay, other research institutes, schools, things like that. So we use the metric system. Even though we're in the United States, we got to be all on the same page for science. So we use the metric system. We also use some stuff from the International System of Units. It's abbreviated SI because technically it's in French, and the system part comes first, the international part comes second in the translation. So SI for international system, but flip-flopped. Okay. Now, the metric system actually ends up being a lot nicer for what we do in science because the conversions from different sizes of the same kind of unit are a lot easier. If I am trying to compare the mass of an apple to the mass of me to the mass of a car, okay, the amount of matter in each of those is pretty vastly different, okay? I might measure my weight in pounds, whereas I might measure the weight of a, car in tons. I could do it in pounds, but that's going to be a very big number, okay? I could do the weight of an apple in tons, technically, but it's going to be a very, very small number. Maybe ounces would be a better fit. Okay, so if I want to go back and forth between ounces and pounds and tons, that takes math. That takes a conversion where you have to do some multiplying and sometimes dividing. So that gets a little bit bothersome. With the metric system, we save a lot of that trouble because we're always using the same kind of base unit. The base unit for mass is grams. For length, it's meters. For time, it's seconds. For volume, it's liters. And then we also have some for chemical amount and for energy that we might talk about later. For now, we're just going to kind of leave those be. Okay? So if I'm talking about a larger amount of mass, okay, like maybe how much I weigh, then I might talk about kilograms, where I tag on a prefix to talk about a larger number of grams. Okay? It's still some kind of grams. The grams is still there, but then I tag on to the front this kilo part, kilograms, or you might say kilograms in the United States. Okay? Still talking about mass, but we're talking about a larger amount. So the number value of my weight or my mass in kilograms is going to be smaller than it would be in grams, but we're talking about the same value. My mass is the same. Okay? Same goes for length. If I am measuring the length of a hiking trail, I might use kilometers instead of just regular meters like from a meter stick, okay? Or you might say it again, kilometers, because it's the United States. Okay? Other common prefixes you probably have heard of are centi, like in centimeters, okay? Or milli, as in millimeters, or milliseconds, or milligrams, okay? So prefixes make our life a lot easier because we just tag it onto the unit, and now we're talking about the same kind of measurement, but to a bigger or smaller extent, okay? When we talk about how we convert between those different prefixes, all it has to do is just move a decimal place around, which is so much easier than trying to do the math of it and multiply and divide and stuff like that, okay? But that's something for, later, okay? Now, if we're going to be taking measurements, we also have to decide when we're right or not. What is correct, and how do we know? So accuracy and precision are kind of our two ways to judge whether we are getting, meaningful data or not. Accuracy basically refers to being on the dot, on the target, okay? Whereas precision means repeatedly you keep getting the same result, okay? So if you are, classic example, throwing darts, okay? If you hit the bullseye, that's pretty accurate, okay? But if you only hit the bullseye once and every other time you're hitting the wall and the TV and your friend, that's not very precise. You're getting a whole bunch of different results even though you were accurate one time, Okay, precise could be that you just keep hitting the same spot over and over and over again, even if it is the spot in the wall next to the dartboard, and you just keep hitting the same hole and it keeps going deeper and deeper. Okay, so accuracy and precision together help us to describe how correct or how good our result is, how good our measurement is doing compared to the true value of something. Okay, so that is the basics of measurement in science. And in this lab, we're going to be doing some measurements with length and with mass. Okay, length, we're using a meter stick. Okay, this is a meter stick. Okay, this is the inches side. We don't want that. We want the side with more numbers. Looks like this. Okay, if I can get in a little closer here. All right, each one of these numbers is a centimeter. Okay, and there are 100 centimeters in a meter. Let's kind of skip to the end here. There's 90 and then to 100. Okay, on some meter sticks, it can be a little confusing because you go 1, 2, 3, 4, 5, you get up to 10, and then it goes 1, 2, 3, and it starts over at 1. That's just because they didn't want to try and squeeze in a whole 11, 12, 13, and then 21, 22, 23. They're just saying that's going to be one more after kind of that last 10 spot you did. So, like right here, would be talking about 22 centimeters, not 20, but also just 2 or something like that. Okay. Now each little dash is also a decimal point for your centimeters. So like if I was like right there in the middle of my fingernail, that would be 22 centimeters plus kind of not quite all the way to 23 centimeters. It's kind of in between. So each one of these little hashes is going to be like 0.1, 0.2, 0.3, 0.4, and this lands me at about 0.5. Okay, so each one of these is 0.1. You might also know, if you're ahead of the game, that each one of those little dashes, all those 0.1s, are actually millimeters. So you could say that up to here is 22 centimeters and 5 millimeters. Or you could say that you have 225 millimeters all the way across here. Each time you go from milli to centi to some other prefix, it's changing by a factor of 10, so it makes the conversion easy, which we'll talk about later. But that's getting a little bit ahead of the game, so we'll kind of back up on that. Okay, so that's our meter stick. Great for measuring things. Recommended not to whack people with, even though it just feels real good to hold it like that. I think it's just a primal thing. Like you just get it and you just want to start swinging it like a sword. But we've got better things to do in a science class than to hit people. Okay, for mass measurements, we're going to be using a digital balance or a digital scale like this. Okay, usually it sits like this. It's plugged in. It's got a little screen that tells you your mass in grams. This one goes out to 1 decimal place, so it could tell me like 15.7 grams. All right, they are pretty sensitive and pretty delicate, so you have to be pretty nice to them. But I'll kind of get to that in a little bit. All right, our lab here is going to be in Unit 1's folder. So we're doing Unit 1, Lab number 1. So I'm going to click to open that up. All right, so Unit 1, Lab number 1, Measurements and Conversions. The first day, we're going to kind of focus more on the measurements, maybe do a couple conversions. And then the second day, we're going to do more conversions that are a little bit tougher, where we're going out of the metric system. Okay, so I'm going to click on this. And that's a typo. That should be U1L1, but I forgot to change it when I copied it over. We've got some resources here. We've got our lab sheet that we're going to be opening with Cami. We've got a reference sheet that has some nice conversions on there with it. We've also got some videos that can kind of help us out on here. So I'm going to open up the lab so we can see what it looks like. Once it loads, it's going to be something like this. Let me erase these here. Okay, in this case, I changed the Word document this came from, but I forgot to update the PDF online. So this number 5 here shouldn't be tin cylinder, it should be crumpled paper. So if yours says tin cylinder twice on number 3 and on number 5, just change that number 5 to crumpled paper so we get the right one. So we're going to be taking the mass of some stuff. We're also going to be taking the length of some stuff. And down here, we're going to be taking the length of some things and then multiplying that, length times width times height, to get the volume of something. Okay, we're going to do our initial measurements of mass in grams using a mass balance. And we'll be measuring length in centimeters down here and down here. Okay, we'll be making some basic conversions with metric prefixes here in part 1. And also, we should be able to calculate the volume just by taking centimeters times centimeters times centimeters, should give us cubic centimeters, or cm cubed, right there. Okay. In the second part, we will convert to a different unit outside of the metric that takes a little bit more math. Also, on the second page, there are a couple questions that have to do with accuracy and precision of your measurements. If you missed kind of the in-class kind of stuff of this, then some of this you won't be able to do on your own. So let's see. That one's okay. That one's okay. Can't do number 13. Okay. 14 is probably okay. Just know that you're going to have people of different heights in your class. So you're going to have some tall people, some shorter people. I always tend to be on the short side. That might help with that. And you should be able to do number 15. So you basically just can't do number 13. You just get a free point off of that if you weren't here in class for this lab. So there you go. Okay. So all that's left now is to take the measurements and do some basic metric conversions.
These mass balances are pretty easy to use. Basically, you just have to set something on top of the little metal plate there, and it'll tell you what the mass is in grams out to 1 decimal place. To turn it on, we just hold down the on button a couple seconds. It's going to calibrate, which means it's got to figure out how to get set up. Now, the air is going to push on it a little bit, so it's got to figure out kind of what that weighs, in a sense. So it's important not to be touching the plate or moving the scale while it's kind of getting ready and calibrated. Once it says 0.0 grams, you should be good to go. So I can take this little tin cylinder here, and I can just place it on the scale. It tells me the mass is 29.1 grams. Cool. Now some things are a little bit trickier. So say something rolls, like this marble, and I try and put it on there, and it rolls off. Well, I could spend 10 minutes trying to balance this on here in a way that it doesn't roll off. Well, that actually was pretty good. But pretend like I couldn't just magically make that rest in a nice spot there. So say if you've got something that rolls or you've got a liquid, we have a trick for this. We set a container onto the mass balance, like this styrofoam cup. Could also be a beaker, a flask, whatever. And it tells me the mass of the cup, which is what it's supposed to do. But then I'm going to hit the on/0 button. So what this does is it zeroes out the balance and basically puts whatever the measurement is at back to 0. So it's subtracting out the mass of the cup. Now if I take my marble and I put it in the cup, that 5.3 grams is just for the marble. Okay? Once I'm done, I can just take it off the scale. But it's still going to try and subtract the mass of the cup, so it's going to give me a negative number, which isn't good. We can't really have negative mass. So before I go and take any other measurements, I want to reset it by hitting the on/0 button again, so it zeroes back to normal with nothing on it. Measuring length with a meter stick can be pretty easy. Each one of these is going to be a centimeter. So this is like 11, 12, 13, 14, 15. And each little hash is going to be a 0.1. So this pencil would be about 19 centimeters. If you wanted to split hairs, you might say like, maybe like 18 point something. But I'd say it's pretty darn close to 19 right on the dot. Okay. For our metal block, to figure out the volume, we want to figure out the length, width, and height of that block, and then multiply those three together to get centimeters times centimeters times centimeters, which is going to be cubic centimeters. Now, you could do that by just saying that this is kind of how I lay it down. So this is my length, and this is my width, and then this thin side is going to be the height. That would be fine. You could also set it up like this and say that now this is the height, and this is the width, okay, and this is the length or whatever. It doesn't really matter which one you say is which, as long as you have three different measurements, okay? It's going to be a long side, it's going to be a medium side, and a very short side. It's going to be the thin one is always the one people forget. The thin side can also be a little hard to measure on the meter stick because this little metal part on the end sort of covers up what's going on here. So it might be easier to start over like at 10 and pretend that that is a 0. Oops. Let's try right there. And then measure it from there. Just give it a little bit more. So something like that.
So let's say I have a metric unit that I want to change the prefix of, so I can talk about something a little bit bigger or smaller than the base unit that I'm using, or whatever I'm measuring with. So I've got some details about myself. We're getting a little personal here. And I want to change the units, but I still want to stay in metric. So I've got my height in meters, 1.65 meters. I've got my mass in grams, okay? I've also got my volume of blood in milliliters. We got a little gross here, okay? And I want to convert these to mean the same value, but be written in a different way with a different prefix, okay? So let's look at this first one here. Okay, my height is 1.65 meters, okay? And I want to change that into millimeters. Well, this is my list of basic prefixes for the metric system, okay? My base unit here means there's no prefix on there. So like regular old grams, meters, liters, joules, seconds, moles, the stuff that's up here, okay? Any of those can fit down in the base unit section, okay? So if I want to change this to millimeters on my chart, I'm going to go 1, 2, 3 spots to the right, okay? Now, since there's a factor of 10 difference between each one of these prefixes, all I really have to do is move my decimal point 3 spots to the right, okay? So I just move it just like I do on this chart. So if my decimal point's starting here, 1, 2, 3 spots to the right. So my answer is going to be 1,650. I'm going to do my best to write with a mouse. Millimeters. Okay, now that's a bigger number. Does that mean that I got taller? I wish. But no, it's just a different way of writing this same measurement. So whether I say I'm 1.65 meters or I'm 1,650 millimeters, it's the same length. It's the same height. Okay. The only difference is how I describe it, the prefix that I use. One of them is probably going to be more convenient to use. Like this is actually probably the better way to put it, and a little bit easier to think of and understand, rather than trying to imagine 1,650 millimeters. Well, let's do another example. Change colors here. So my mass is 68,039 grams. Well, kind of like this, I can't really imagine what that looks like, what that would feel like to have 68,000 grams of something. So I'm going to change this to kilograms instead. Okay, grams is a base unit just like meters. So I'm starting from this center point here, and I'm going to move to make this kilograms. So I'm going to kind of go 1, 2, 3 spots to the left on my chart. And my decimal point is going to do the same thing. Now, if I look at this number, I don't see a decimal point. But if you don't see one, it's just not shown at the end of the number, all the way over on the right. So my decimal point is actually right here to start with. Okay, now to change that to kilograms, I've got to move that 1, 2, 3 spots to the left. Okay, so in kilograms, or kilograms, however you want to say it, 68,039 grams is the same as saying 68.039 kilograms. kg for kilograms. Okay, well, let's do one more. So my body has 5,380 milliliters of blood in it. So if you were to go like full vampire and just suck out all my blood, then that's about how much there would be. Okay, now in this case, I'm starting with milli as my prefix. I'm not starting with just regular liters. I'm starting with milliliters. Okay, so I have to start over here instead. But I still want to move to a different prefix. I want to move to kiloliters. Okay? It's also good to mention again here, it doesn't matter whether I'm using meters or grams or liters. All of these work the same way. The only thing that changes on this chart is the prefix. Okay? So if I'm starting at milliliters and I'm trying to get to kiloliters, I've got a long ways to go. I've got to go 1, 2, 3. We do count that as a spot. 4, 5, 6. 6 spots over to the left. Well, okay. So to get my answer then, I've got to move my decimal point 6 spots to the left. Okay, again, I can't see my decimal point, but it's got to be all the way over on the right at the end of the number, so it's right there. Now, if I go 6 spots to the left, past the 0, past the 8, past the 3, past the 5, and I run out of numbers to go past. Okay, that's kind of happened up here, and I kind of breezed over it, so let me talk about that real fast. In this first one, I moved, boom, 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 3 spots to the right, and I ended up moving past no numbers. So I threw in a 0 just to kind of fill that spot. We do the same thing if we're going to the left, and we run out of room. We run out of numbers to go past. So I went 1, 2, 3, 4. I've still got 5, 6. Okay, so I got 2 more spots to move. So I'm just going to fill those in with zeros, and my decimal point lands at the end over here. So I don't have much room over here, so I'm just going to kind of squeeze it in down here. So my answer is going to be 0.0, 0 for those 2 blank spots I moved past, and then the rest of this 5, 3, 5, 3, 8, 0. And my unit is now kiloliters. K for kilo, L for liters. If you want, you can put a 0 out in the front of this. I think it makes it look more complete that way, rather than just leaving it as 0.005380, but it's technically fine either way. Okay, and that's the basics of changing your prefix and making the correct conversion in the metric system. Okay, as long as you know where to start on the chart, And as long as you move to the unit you want to get to and do the same thing with your decimal point, the conversion is pretty easy. So if I wanted to change from like hectoseconds to deciseconds, I'd have to go from hectoseconds to deciseconds. Again, it doesn't matter that it's seconds. It could be grams. It could be hectograms. But I'm just looking at the prefix. And I move 1, 2, 3 spots over to the right. And my decimal point would also move 3 spots to the right. Okay, so look at where you start on the chart and then always move to what you're trying to convert into. Now also be aware, deca and deci are very similar. Okay, so be careful with this. Deci, the smaller one, is just a D, and deca, the bigger unit, is DA. Okay, and a lot of times you also see this as DECA instead of DEKA. I think I actually have that changed in other versions, and I forgot to change it on this. So if you see that, it means the same thing. Okay, so if you see like DAG, that's decagrams. DG would just be decigrams. Okay, and those are 2 different units. They mean 2 different things and 2 different values. So be careful of that. So I can do some simple metric conversions with the data I get over here, like my grams and my centimeters. So if I take my 29.1 grams and I want to change it into centigrams, well, I've got to move my decimal point around. Okay, if you look at the chart, grams is on your base unit, and to go from base unit to centi, you're moving 2 spots to the right, past deci, and then you get over to centi. So my decimal point should do the same thing. Okay, let me do this in a different color so it stands out. So I'm going to move this past the 1 and then past an invisible 0. So in centigrams, this 29.1 grams is going to look like this. 2910 centigrams. Okay, and we're going to do that for all of these. We're going to change grams to milligrams or to kilograms. Again, watch out. Decigrams and decagrams are 2 different things, so be aware of that. We're also going to convert these ones down here.